Hello everybody and welcome to another session in the Vitrolife Academy studio. I'm Jaco Terblanche and I'm going to show you how to do the vitrification using the Rapid Eye kit from Vitrolife. So there's three components that I would like to talk to you about. And the first is the actual hardware. We're going to talk about the media, but then also the protocol. So if we start with the hardware itself, when we do vitrification, we always need a container in which to store the liquid nitrogen. And here I have the latest edition of the Smart Box, ergonomically designed to make it very user-friendly. It's got handles in good positions to handle the box. It has a specially designed slot on top where you can place your straws. It has built-in magnets on the inside. So it's designed with a lot of good features and things taken into account to make your life as an embryologist very easy. If you want more information on this, you can get a lot more at the stand at our booth itself. With regards to the device, we have straws that are individually sealed, and in each packet of these you will have the Rapid Eye straw as well as the Rapid Eye itself. And the Rapid Eye, of course, is where you will eventually load the embryo. So with regards to the straw, you will have a small piece of metal that's already incorporated into the straw, and that piece of metal, of course, gives it some weight when you are storing it in your storage container, that it doesn't float up inside the tank. But this small piece of metal also attaches to the magnet inside the box, so it makes working and handling a lot easier for the embryologist, that your straw doesn't fall around or move around when you work with it. Then we also have certain markings on the straw. We have these black lines. The bottom black line is a warning sign. Obviously, when we work with vitrification, we have to have the embryo submerged under liquid nitrogen. And that level, or that mark, then shows you the minimum level where liquid nitrogen should be when your straw is inside the box. The straw also comes in different colors. This one is a blue color, but there's different colors for identification for your patients. And then the other thing that you will find is that there's a metal rod inserted inside the straw when it's inside the packet. Now, there's two major reasons for that. First of all, when we finish or when we do the vitrification, you will have your Rapid Eye inside the straw. Now, to prevent it from bending or kinking, we have this metal rod inside, so it keeps it nice and rigid and straight. But the other very important reason we have it here is to prevent condensation on the inside of the straw. Remember, we're going to place the straw inside the box that is filled with liquid nitrogen. And if the metal rod is not inside the straw, you will find that the water vapor in the air will form condensation on the inside of the straw. And that water vapor can, of course, be detrimental to the embryos that you will eventually then place inside on the Rapid Eye itself. So a little bit more about the Rapid Eye. I actually have one here on the screen for you to look at. The one side has this hole inside the plastic rod, and we place the embryos inside this hole. There's not a top or a bottom side. The embryos are held in position by surface tension. And one of the great benefits of that is that the embryo doesn't sit on a piece of material. So when it comes to warming, at least, you don't have to take a pipette to remove it from this device. It immediately turns from a solid state into a liquid state and falls into your media. So it makes working very straightforward, very easy. The hole itself is the volume of about 30 nanoliters. It's very small, and therefore also it means that you have a very strong surface tension to keep your embryos in place. When everybody in the team and everybody in the embryology lab load exactly the same volume, in other words, they fill the hole completely, that's when they will see more consistent results, because everybody will use exactly the same volume during vitrification. A little bit about the products that we use for vitrification. Now, in our media, we have stage-specific kits, and we also have a product called Omni for all different stages of embryo development. The stage-specific kits, you obviously will follow the specific protocols and the timing designated for that type of protocol. So what is unique about our vitrification media is the fact that we have MOPS as a buffer. So that means that pH is controlled during this very critical stage of vitrification and embryo handling. We also have hyaluronan in our media, and the hyaluronan we know has cryoprotective properties. It protects the embryo during this really big change that they undergo through from being cultured in vitro and then going into a vitrified state back into culture in vitro. So the hyaluronan helps it. And then the cryoprotectants that we use is ethylene glycol and propanediol, as well as sucrose in the warming solutions. So this combination of cryoprotectants, hyaluronan and MOPS provides a really safe environment for your embryos to be in while you are doing the vitrification. One of the unique things about this protocol is also that we use 37 degrees Celsius. We believe that it's a more physiological temperature to work at, and it also helps you in the lab that you don't have to switch the heated stages on and off. You can always keep it at 37 degrees Celsius. One thing to note is the fact that most metabolic procedures happens faster at a higher temperature, and therefore also our protocol allows you to work much faster because the penetration of the cryoprotectants will be much quicker across the membranes into the cell. So it'll save you time in the end. So if you take the temperature in mind, the volumes that we work with, the concentrations of the cryoprotectants and the timings, that gives you a very good protocol to work with. Okay, so I want to now explain a little bit more about the protocol for you. The embryos will be placed in the media will be placed in a 4-well plate, or a 5-well plate rather. We prefer this type of 5-well dish where we know the bottom or the bottom of the well is in direct contact with the heated surface, and that helps you to maintain that temperature at all times. So you will aliquot between 0.5 and 1 ml of each of the 3 solutions into the 5-well plate and warm it up to 37 degrees Celsius. Now we often get the question, so how long does it take to equilibrate? And that is something that you have to validate in your own laboratory, because each of ours, the equipment in our labs are different, the room temperature is different, and that will impact the timing. But I would say typically between 15 and 20 minutes in a 5-well plate where you have direct contact should be sufficient to heat up the media. Remember, we contain MOPS in this product, so never place the media inside an incubator with CO2. Either heat it on your heated stage or with an incubator without CO2. So once your dish is ready, you will place your embryos into the first solution, and we keep them there for a minimum of 5 minutes. Now the reason we have them in this solution is that it gives you the opportunity, if you are doing assisted collapsing, to do it during this first stage. We have seen a lot of publications where people have increased results when they do assisted collapsing. And that in that environment, in the 5-well dish, it's a safe environment to do this assisted collapsing. Following the 5 minutes, you have a very quick step, 2 minutes into the second solution. And obviously always when you transfer embryos from one solution to another, make sure that you prime your pipette first, and that will allow you not to dilute the concentrations of the cryoprotectants as you go from one well to another. Now, just before you reach the end of that 2 minutes, you're going to make 2 microliter droplets, 2 50 microliter droplets of the third solution. So your embryos are not actually going into the third solution, you're going to create them on a separate surface. So I'm going to do that now. I've got some some glass beads in my in my dish, and that's what I'm going to use for the demonstration. So there you can see the glass beads. I'm going to pick one of them up, transfer them to my second solution, and you will quite often see that due to the differences in the cryoprotectants, your embryo will float to the top. At that point, just take it back from the surface and put it down on the bottom. So now we are in our 2-minute solution, and as I said, as you reach the end of towards the end of the 2 minutes, we use a micropipette, and with this we will aliquot 2 drops of 50 microliters. I tend to make the droplets close enough so that I have them in one field of view, That just makes handling a lot easier. So in the meantime, you've placed your straw inside the smart box. The air inside that column of the straw has cooled down to minus 196 degrees, so we can do vitrification instantly inside that column of air. So the 2 minutes is finished. I'm going to pick up my one embryo, rinse it in the first droplet, expel the remaining media, and then move it to my second droplet. So here I find my embryo. I'm moving it into the first droplet. Discard the remaining media to not dilute the concentration. Prime my pipette again. Oh, made a bubble there. Move it into the second droplet, and now I'm ready to load it onto the rapid eye. There I have my embryo inside the hole, and immediately I remove the rod and place the rapid eye inside. So the vitrification takes place instantly because that whole column of air has been pre-cooled to minus 196 degrees. And at this stage, I then make use of the ultrasonic sealer that we have. It has a mouthpiece that fits very gently over the straw, and I can hold it there, and it takes about 4 or 5 seconds to seal the straw, and we end up with our vitrified embryo. The unique thing here as well is that our embryo never touches liquid nitrogen. And that, obviously, in the last few years, where we've seen things like the pandemic and you know the sterility of the liquid nitrogen is very important. And at least in this type of closed system, your embryo is never in contact with liquid nitrogen. So that's a very safe way of handling your embryos. Once your embryo is vitrified, you can introduce whatever storage device you are using. For instance, here I have a cane with a goblet, so you have a wide part where you can introduce it. Make sure that your container, the smart box, is filled all the way to the top, and you can now safely, under the level of the nitrogen, place your straw inside the goblet or the VisiTube, whatever you are using, and from there it can go straight into your storage tank for long-term storage. So very straightforward. I would say the most important things to learn is just that initial amount of media that you need to place on the rapid eye in order to load the embryo. Once you get that right, everything is very easy. And we've seen from feedback from a lot of labs is once the embryologists have learned that step, the results are much more consistent among everybody in the lab, and it's not dependent on their skills because we are able to standardize the actual workflow here. So if you think vitrification was easy, I'm now going to show the warming, which is even easier and more straightforward. So in the same way, you will prepare your warming dish. We still use the 5-well plate because you have a very good temperature transfer between the heated stage and the bottom of the dish, and therefore the media in the dish. And again, you need to validate how long it will take in your own lab to reach at least 37 degrees Celsius in the media. So then again, you will bring your goblet or VisiTube from your storage container, place it in the large bath, the gap that you have there. And once you've done the identification, you've picked the right straw for the right patient, you place it in position, and again it's neatly held in position by the magnet, so it's not falling around. It makes working for the embryologist a lot easier. We then make use of a very simple circular cutter, and the reason why we use this is that we don't want to pinch the straw and make difficulty for you to eventually retrieve the rapid eye. So we will lower it over the top, and as I mentioned earlier to you, the one side of the rapid eye has a black dot, and that is to help you to visualize where the top end is. Now, you never want to cut through the rapid eye. Remember, this has been vitrified and stored at minus 196 degrees, so it does become quite brittle. You can rather cut a little bit higher and cut again than cut too deep. Okay. So in order to do that, what I usually do is I take the very fine needle nose tweezer, I hold it in position right at the height of the black dot, and if I then lower the cutter over the top, I know I will not cut through the actual rapid eye, and it's safe. So now I've opened up our closed system, but I've not placed any pressure on myself or on the embryo because it's still vitrified. It's still in the bath of liquid nitrogen. So now, in your own time, place your dish at a very optimal distance, as close as possible. We have seen that the warming rates are much more important than cooling rates. So this is a very critical step. So you're going to reach in with your needle nose tweezer and grab the tip of the rapid eye. And you only lift it up until you can actually hold it with your fingers. Don't move it around with the tweezer because it's very small. And you don't have to be concerned that the temperature from your fingers will affect the embryo because there's no conductivity through this plastic. And also it's submerged in liquid nitrogen at this stage. And now in very one quick movement, you go directly into your first warming solution. And then if you have done a good job with the vitrification, you will see that the embryo will just float away from the rapid eye. And there it is. And this is the really nice part about it. As I said before, your embryo is not in contact with a plastic surface, and we've seen this with some of the devices, that when it gets stuck on that plastic, you sometimes have to use a different pipette to take it off that device. And then once it's inside your first solution, you just follow the protocol. For blastocysts, for instance, we have 2 minutes in the first solution, 3 minutes in the second solution, and a final 5 minutes in the last solution. But depending on the type of or stage of embryo that you will develop, warm and vitrify, you follow that specific protocol. So very straightforward. Obviously, once you've done through the last solution, you will go into your culture dish or your embryo transfer dish, whatever your protocol dictates. But very safe, easy, consistent, and it's a closed system. There was a lot of debate in early years about which is better. Is it a closed system or open system? And nowadays there's a lot of data provided showing that actually if you follow the protocol correctly, there's no difference between the results that you can achieve between open and closed systems. So we know it works, and if you would like to get more information, I'd invite you to our booth here, and you'll be able to see a lot more of the products, the studies that have been performed, and yeah, we can help you there. Any questions? Yes? Sorry, I'm going to give you the... Just hold it close to your mouth. It's on.
The procedure of vitrification for oocyte different from blastocyst or cleavage stage.
So, as I said before, we have stage-specific kits. We have a kit specifically for oocytes, but we also have a kit for all stages of development. And the protocol is slightly different. So we still use the same cryoprotectants, ethylene glycol and propanediol, but the exposure time to the oocytes is slightly longer because they are more complex cells. But we use the same media, but the timings are different.
Thank you.
Sure. Okay, well, thank you very much. Thanks for joining us. Bye-bye.